In today's lesson, we're going to talk about simplifying radical expressions. Now, new concepts. Some of this will be review, but we will have some new concepts within here. Because 4 squared is 16, 4 is the square root of 16. However, we also have negative 4 squared is 16, so negative 4 is also a square root of 16. To indicate that the positive or principal square root is desired, the radical symbol is used. Therefore, the square root of 16 equals 4 and only 4. The expression under a radical sign is the radicand. So the square root of 16 is a radical or radical expression, and 16 is the radicand in that scenario. There are also other roots other than square roots. For example, if we know that 2 to the third power is 8, because 2 times 2 times 2 is 8, so 2 is a cube root of 8. And then also because 3 to the fourth power is 81, and negative 3 to the fourth power is 81, negative 3 and 3 are fourth roots of 81. Talking about n roots. Given that a and b are real numbers, and n is an integer greater than 1, if a to the n equals b, then a is an nth root of b. So if I were just to put a quick example of that, let's say a was 1, a was 2, n was 3. We know that that means that b would be equal to 8. So we know that 2 is a root of 8 because, and not only that, we know that it's a third root because 2 times 2 times 2 is 8. So 2 is a third root of 8. You could do that with just about any number in that way. So given that a and b are not negative and n is an even integer greater than 1, or given that a and b are real numbers and n is an odd integer greater than 1, if a to the n is equal to b, then the nth root of b is equal to a. So that also kind of applies that square roots and something squared would be inverse functions of one another, or they would undo one another. The same thing as if I had 2 to the third power, if I did a third root, that would undo this, and I would have the third root of 8 equals 2. A little bit more for definitions. For the nth power of b, n is the index. When n is not shown, it's assumed to be 2. So that means that we're taking a square root if we don't see a number. However, if we do see a number, that means we're taking a different root. So for this first one, we're actually taking a fifth root. So we're asking ourselves, what number times itself 5 times gives us negative 32? So it's going, anytime you're dealing with roots, you're going to be dealing with small numbers. So this would be equal to negative 2, because negative 2 times negative 2 equals 4, times negative 2 equals negative 8, times negative 2 equals negative 16, equals positive 16, and then times negative 2 is equal to negative 35. So notice I have 1, 2, 3, 4, 5 negative 2's there. So that means that negative 2 to the fifth power equals negative 32. And just like I said before, that would mean that the cubed root, or the fifth root of negative 32 would be negative 2. So that is our answer. For part B, we're asking ourselves what number times itself 3 times equals 27. That would be 3, because 3 times 3 is 9, times 3 is 27. And last, the fourth root of 16. So that would either be 2 or negative 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. The same way, negative 2 times negative 2 is 4, times 2 is negative 8, times negative 2 is positive 16. So for that one, you would have 2 answers. All right, the product rule for radicals. So if you have a number underneath, you can break that number apart if it helps you simplify a problem down. So given that a and b are real numbers and n is an integer greater than 1, we can do what I just said. So for example, if we had the square root of 10, we could break that down into the square root of 5 times the square root of 2. If we had the square root of 20, that can be the square root of 5 times the square root of 4. That second example, that benefits us because we know that the square root of 4 is a perfect square. Square root of 4 is 2, so we could simplify that as 2 root 5. So the square root of 20 is equal to 2 square root 5. And then if we have a power underneath a radical, or if we're taking like the square root of something and that radicand is a number being squared or raised to the third, fourth, fifth, so on and so forth, then these properties apply. So we could rewrite that as a fraction. And then if that's odd, if n is an odd number, then we can rewrite that. You can see that we can break one of those pieces off and multiply it by another square root of x. Okay, I'll explain that a little better in an example. So this first one, we have 8 times 5. We know that 8 times 5 is 40. So we could break 40 down into the square root of 4 and square root of 10, which equals 2 root 5. So you can see the way that they broke each of those down, or multiplied it and then broke it down in a different way so that they could simplify it. For the second one, I know that 54 times 2 is, 54 divided by 2 is 27. So I could take the cubed root of 27, which is a cube root that I know, times the cubed root of 2, which is one that I don't know, and I could simplify it in this way. I know that the cubed root of 27 is 3, so I could have 3 times the cubed root of 2, and that would be my answer. For this last one, I'm taking square roots here. I'm just going to divide a couple things. 567 divided by, let's try 9. So this is equal to 9 times 63, so that would be the square root of 9, times the square root of 63, which I could rewrite as the square root of 9 times the square root of 7. So I know that the square root of 9 is 3. Square root of 9 is 3. Multiply those together and we would get 9. So this answer would be 9 root 7. So what I did there to figure out what I could break it down by is I just took a calculator and said 567 divided by what number could give me something that I can work with, and I found 9. All right, so if we're adding or subtracting these different things together, we know that the cube root of 8 is 2. 2 times 12 is 24, minus cube root of 8 again is 2, plus, now square root of 8 we're going to have to break down. I'm going to break that down into the square root of 4 times the square root of 2. Square root of 4 is 2. So I could take whatever number is out in front and multiply it by 2 root 2. So this first term is going to give me 10 root 2. And that second one, 9 times 2 root 2, will give me 18 root 2. If that doesn't make sense, just realize that this is being substituted in for that square root of 8, because I just said that that could be broken down in that manner. From here we can simplify. So I'm going to have 24 minus 2 is 22, plus both of these are square root of 2, so we can break or we can combine those two as 28 root 2. There's our answer for that one. Moving along here. So this first one, if I divided by 2, that would give me square root of 121 times square root 2 plus that second piece I can break down into square root of 9 times square root of 8, which I know is square root of 4 times square root of 2, minus, again, 48 is 8 times 6. Square root of 8 is going to be square root of 4 times square root of 2 times square root of 6. So we'll see even further if when I multiply or break some things down, if I can simplify them even more. So this first piece will be square root of 121 is 11, so 11 root 2. Square root of 9 is 3, so 3 times square root of 4 is 2. 3 times 2 is 6 root 2, minus square root of 4 is 2. And then right here I have 2 times 6 would give me square root 12. I could re-break that down into square root 4 and square root 3. So that would be 2 times 2 is 4. So 4 root 3. And then I can simplify from here. So 11 root 2 plus 6 root 2 is 17 root 2 minus 4 root 3. Can't add those together or subtract them because we have different roots. Okay, and then dealing with this next one, we have the fourth root of 32 plus the fourth root of 2 plus the fourth root of 162. So for this first part, if I were to break that down, divide by 2, I would have the fourth root of 16 times the fourth root of 2 plus the fourth root of 2 plus that 162. I can break that down into the fourth root of 81 and the fourth root of 2. So over here, the fourth root of 16 gives me 2 plus 1 fourth root of 2, and then the fourth root of 81 is 3, so plus 3 fourth root of 2. So then we just add those numbers out front together. That middle one would be a 1. So we have 2 plus 1 plus 3 gives us 6 fourth root of 2 would be that simplified down. Okay, I'm going to finish this one a little bit fast. So if we have x to the, or the square root of x to the fourth, anytime we have a square root, we can think of that as being to the 1/2 power. A third root could be 1/3 power. So we have x to the fourth over 2. That'll just give us x squared. Now again, that 2 in the denominator of that power came from that square root of x. This is the same as x to the 1/2 power. And then we add the x to the fourth, so that simplifies down to just this. Now, as I said, I would explain that odd power from that rule that we had earlier. So first, I'm going to deal with the numbers. That would be square root of 9 and square root of 2. So we have 3 root 2. If I'm dealing with h to the 17th underneath a square root, I can break one of those off. So that would be 1 less, or the square root of h to the 16th times the square root of h. So the square root of h to the 16th can be h to the 16th over 2, which equals h to the 8th square root of h. Now I can simplify everything that's outside and everything that's underneath. So this final answer can be 3h to the 8th square root of 2h. Let's see if I got that in time. And I got some seconds to spare. So take your time and re-look at things if they were confusing. I know I went a little fast today, but I wanted to get through all of the ideas in this topic. Hope you guys have a great day.